What's up, mathematicians? My name is Justin and welcome to my channel, Grid Math. As you can see on this channel, I'll be doing math with pencil on grid paper. This is my very first video. Pretty excited about that. I hope you learn some things. I hope you enjoy the video. If you do, please consider helping me out by subscribing. In this channel, I'll be focusing first on my true love, geometry. Hopefully we'll have time to cover other subjects, other branches of mathematics later, but we're going to start with geometry. Our approach to geometry is going to be influenced by history, by important mathematicians, and by axiomatic systems. I'd like to start by laying out a roadmap of where we're going to be headed. And to introduce that roadmap, I'd like to show you a couple of photos. So the photo on the top, the object you see on the top, is called the Lobombo bone. It is the oldest known mathematical artifact on our planet. It's dated back to anywhere from 35 to maybe even 40,000 or over 40,000 years ago, depending on who you ask. It was found in the Lobombo Mountains near the border of Swaziland and South Africa. Now, we don't know exactly who made this bone or why they made it. People have different theories on that, but it seems pretty clear that it was used for counting, some kind of counting. The second object you see here is called the Nippur cubit, and it's the oldest known measuring device or ruler that archaeologists have found. I'm sure there were measuring devices that humans use far older than this, but this is the oldest one that archaeologists have found. And this particular measuring device dates back to about 4,600 years ago. So how do these two objects set up our roadmap? Well, let's start it here. We're going to say, and I recommend you take notes as well if you have a notebook. We're going to say, here we go, we have math beginnings. Did I misspell that? I think I did. I've got to make sure I keep my spelling. This is another reason I like to use pencil, so I can always go back and fix any mistakes I make. Sharpies with different colors would look better, but I'd rather be able to fix my mistakes. It's hard for me to talk and work at the same time, apparently. All right, so we have math beginnings, and with the Lobombo bone, it indicates one of the first things that human beings did, that like one of the first mathematical activities that human beings were engaged with was counting. So we'll put counting here. And the Nippur cubit would indicate that another one of the early mathematical activities that humans engaged in was measurement. So I'll put measurement here. So I'm not saying that these are the only two mathematical activities that early humans were involved with, but they were two of the earliest, and they're important for different reasons. So let's look at the counting thread first. So the development of counting eventually led to the development of numbers. And once human beings had numbers, this led to the development of arithmetic, basically operations on numbers. And after doing arithmetic for a while, human beings eventually developed algebra. There was another concept that also plays into this, the idea of a variable or an unknown quantity. Sometimes we knew the numbers that we're dealing with, and sometimes there was sort of an unknown quantity we're dealing with. And so we typically use x to represent an unknown quantity. So the combination of rules of arithmetic plus working with unknown quantities or variable quantities, quantities that we want to be able to change, we get the discipline of algebra. Okay, but what about measurement? Because that leads more directly into what we're going to focus on in this course, at least, for now on this channel. Eventually, I would love to do a lot more with algebra, but for now we're going to focus on this thread over here. And so this idea of measurement leads to geometry. In fact, the word geometry comes from the Greek, where geo means earth, and metry means measurement. So geometry could be thought of as just coming from the words earth measurement. So now I'm oversimplifying a lot here, by the way, and I recognize that, but I want to paint in broad strokes for now. So this idea of measurement. Now, I mentioned the Nippur cubit, and I showed you a picture of it earlier. That was found in the region of Babylon or ancient Sumeria. And so the Babylonians and also the Egyptians, didn't give myself too much space here, but they were involved in measurement and contributed significantly to geometry, how geometry first sort of got started by their studies of measurement. Egyptians, for example, they built pyramids and they charged taxes based on land areas, and all these things involved measurement. Well, two important early Greek mathematicians, in fact, sort of the two key founders of Greek geometry, learned from these Babylonians and Egyptians. In fact, historical records indicate traveled to Babylon and Egypt and learned from the geometry that those societies had and studied. So these mathematicians are Thales and Pythagoras. So you may have heard the name Thales before. If you studied philosophy, I'm sure you came across it. And Pythagoras, you have almost certainly heard that name before, if nothing, if in no other context than connected with the Pythagorean theorem, which, by the way, Pythagoras did not come up with the Pythagorean theorem. It was known. Historical records indicate that it would have been known in some sense, at least to the Babylonians and Egyptians. Ancient Indian mathematicians were aware of the Pythagorean theorem long before Pythagoras. So this is not original to Pythagoras, but for whatever reason, we've attached his name to the theorem. So Thales and Pythagoras learned some geometry from the Babylonians and Egyptians. But they weren't satisfied with at least Pythagoras wasn't satisfied with the more Egyptian approach to geometry, which is like, okay, let's find the area of this land so we can figure out the right amount of tax to charge this farmer. Thales and Pythagoras were interested in pushing geometry a bit further and moving it beyond just measurement into the study of forms and also involving proof. Okay, so forms are things like triangles, circles, basically these sort of perfect ideal mathematical objects. And so basically the work of Thales and Pythagoras moved forward the Greek and human understanding of forms and proof. And so the geometry that was inherited from Babylonians and Egyptians and other peoples as well led to an advancement in this understanding of forms and proof. Now, in order to prove things, there's another concept we have to bring in here. That is the concept of logic. In order to be able to prove something, you need to be able to use logic very explicitly. Now, it's certainly the case that logic was used by Babylonians and Egyptians and other people as well. So I'm not saying logic started at this point with Thales and Pythagoras, but this is where it started to get a bit more systematized. And in fact, the person who is credited with really systematizing logic is Archimedes, another name that I'm sure you're familiar with. So Archimedes, important Greek philosopher, is and often considered sort of the founder of logic, in at least formal logic. So these ideas come together to develop the concepts of abstract forms and logical proof. Okay, so where do we go next? Well, as these mathematicians, it wasn't just Thales and Pythagoras. Pythagoras was involved in a society of mathematicians, and so many mathematicians were involved in proving different things and discovering things about different forms. And they also did things with numbers and arithmetic as well. It's not like they were only doing geometry, but in the realm of geometry, where this eventually led, as more and more theorems got proven, mathematicians started to think about the general structure that all these theorems, all these facts that they believed to be true, how could that all be put together? This led to what I think of as one of the most important and key concepts of geometry. I mean, mathematics in general, but in the way that I teach geometry, that concept is the axiomatic system. So axiomatic systems are logical structures that we can put these facts, these theorems that have been proven about the different forms into. Now, a number of people contributed to the development of axiomatic systems, but the big one that we are really going to be focusing on this class, is a guy by the name of Euclid. You've probably heard the name Euclid before. You may be aware that Euclid is often called the father of geometry. So I think some people misunderstand that, think that Euclid came up with all these proofs, all these geometric facts, and that's not true. Euclid wasn't even the first person to structure them in a sort of axiomatic system. Hippocrates of Chios, I don't know. I should look that up, but was also an important early developer of the idea of axiomatic systems. But Euclid wrote this book called The Elements, which laid out geometry in the axiomatic way, and therefore is the name that's really attached with this idea, originally developing the axiomatic system. The Elements is usually considered the most important geometry book ever written. So, okay, now where have we gone? We started with the beginnings, counting and measurement, early human activities, early human mathematical activities, and we have these sort of two threads. Now, it's certainly not the case that these were completely separate. Euclid, for example, did algebra, and he solved algebra problems using geometric techniques. So there were connections between algebra and geometry, dating way back. And also Persian mathematicians and Babylonian mathematicians used geometric techniques to solve algebra problems. So there's a lot of connections between these disciplines. But there were also these sort of separate threads going on. Well, then there was the development of a discipline of mathematics called analytic geometry. I'm spelling things wrong here, my apologies. I'm not used to talking and writing. Okay, so Analytic geometry. This is sometimes called coordinate geometry. Basically, analytic geometry is geometry done, oops, you can't even see what I'm writing there. So analytic geometry or coordinate geometry is geometry, couldn't even tell that I was making a spelling mistake. Shouldn't have told you about that. But this is geometry done on the coordinate plane. Basically taking the concepts of algebra and combining them with geometry, the forms, and knowledge of geometry, bringing those things together into a sort of unified discipline, right? So we have algebra coming in here, and we have all the things from geometry, not just axiomatic systems. So ideas of forms, proof, and geometry in general. This thread also coming in here. And analytic geometry is sort of a unification, one could say, between algebra and geometry. Now, who is involved with this? A lot of people, honestly. This idea of a graph, dates back to, it depends who you ask. One actually sort of interesting figure in this history is a mathematician by the name of Omar Khayyam. You may recognize that name as the name of a famous Persian poet. It's unclear whether the poet and the mathematician were actually the same person. Oftentimes they're thought to be the same person, but historically that's not clear. Omar Khayyam contributed significantly to the development of algebra by working on solutions to the cubic. Also contributed to axiomatic systems by investigating some of Euclid's assumptions, specifically the idea of parallels and Euclid's parallel postulate. We'll get into all that later if you don't know what that terminology means. Also contributed to the development of analytic geometry and just the idea of a graph in the way that he worked on some of his algebra problems. And there were many mathematicians, other mathematicians as well. The two that are sort of typically credited with developing the field of analytic geometry are two French mathematicians by the name of Rene Descartes and Pierre de Fermat. So Descartes and Fermat end up sort of getting the credit for developing analytic geometry, although there were many others involved with it as well. And one other thing before we go, sort of an extra branch off axiomatic systems and forms and all these other things, is the concept of curved space. I would just want to highlight that because it is something we'll be spending a bit of time talking about on this channel. In this course, as we go through geometry, some of the history of geometry and the important developments. And there are a number of mathematicians connected with this as well. I'm not really going to list them all, but people like Gauss, Einstein, Miriam Mirzakhani, who was the first female mathematician to win the Fields Medal, they all contributed to this field of curved space. And we'll be looking at that in this channel as well. So just to recap, we have here mathematical beginnings, and if we want to take sort of a historic perspective on it, just a quick historic overview. When on the geometry side, mathematics started, or geometry rather, started with measurement, and the Babylonians and Egyptians, there were other societies for sure doing it as well, but in the thread that we're looking at, Babylonians and Egyptians developed these techniques for measuring for different practical purposes, construction, taxation, that sort of thing. The sort of applied mathematics of the Babylonians and Egyptians was taken by the Greeks, Thales, Pythagoras, and others, and made more abstract. And the Greek mathematicians were the ones who are credited with really moving geometry forward in a big way. geometry was studied by all the famous Greek philosophers. Well, maybe that's not true, but definitely, yeah, actually, I don't think Socrates really studied geometry, but definitely Plato and Aristotle and a lot of these philosophers. If you went to Plato's school of philosophy, you definitely studied geometry. In fact, there's a saying that, there's historical evidence to indicate that the entrance to Plato's school, there was a sign over the entrance that said, let no one ignorant of geometry enter here. So geometry is considered very important to the Greek academia. So after the sort of practical applied measurement techniques of the Babylonians and Egyptians, we get the development of more pure mathematical abstract geometry by the Greeks. From the Greeks, the Greek knowledge basically went to the Persians and the Arabs, mathematicians including Omar Khayyam and many other important Arabic and Persian mathematicians, sort of held on to and moved forward that Greek tradition of geometry. And then eventually the works of the Arabs and also the works of the Greeks that the Arabs had sort of kept and continued to translate and copy made their way to Europe, and people like Descartes and Fermat and others sort of inherited the knowledge that, this thread of knowledge that, started here with Babylonians and Egyptians, through the Greeks, through the Persians and the Arabs, and then eventually to the Europeans. And so, we have this situation where we credit Descartes for, creating this discipline of mathematics. And certainly he was an important figure, but it's important to understand that there's a lot of history and a lot of different mathematicians from different countries, different societies, male and female, that contributed to this development, this unification of algebra and geometry. So we're going to wrap up there. I hope this roadmap gives you an idea of, a good introduction to what we're going to be looking at in this course. And I hope you found this interesting and helpful, and I hope to see you in another video. Thanks so much. See you next time.